Hi, you can see we have a DEM of the Durham area. We can perform some landscape analysis using our spatial analysis tools. If I go to Tools, instead of looking at my neighborhood operations like we've done already, we have density, conditional. We'll talk some about these in our other classes, but I can go to Surface and I can calculate aspect. Aspect is the direction that something faces. We've got slope, identifies the slope or gradient from each cell of a raster. We've got a view shed, and we can even create contours. Now we're going to calculate our slope here. So my input raster is going to be my DEM. Now I can calculate it using other types of data, but it's probably not going to make much sense there. My output measurement could be in degrees, my methods, and I can calculate these Z factors. And if you just clicked on this, it makes sure that your X and Y units agree with your Z units. And for now, I'm just going to calculate this. There's a Z factor that you can change if they're not equal to each other. I'm going to run this. And then this is my slope. And all it does is just calculate. And so now we can see areas that have the highest slope. And if I were to zoom into these areas right here, uncheck these, you can see, looks like a kind of a river flows through this particular area right here where we have the highest slope. So we have low slope and high slope. And we can run other tools that we've talked about before with math algebra to look for all the areas that are less than 2 degree slope for places such as standing water. So you can see an example of slope. Now other types of tools that we have, we've got aspect, the direction that something faces. So I'm going to look at DEM. Now what this runs are angular values from 0 to 360, and then we look at flat. So our straight north is going to be 0, 337.5 up to 22.5. This is kind of 45-degree angle here. But from 0 to 360. And these are relatively arbitrary values, so me saying my aspect is 273 doesn't mean it's better than 47. The 47 just means that it faces to the northeast versus the 273 that faces to the west. So this is an aspect. So you can see areas that face to the north and south, or northwest and north, versus the southwest and south. And see what angles, maybe exposure to the sun and whatnot. Last one we'll look at here is hillshade. So we got hillshade. And so we can have our hillshade using our DEM. And so we can put up a hypothetical sun with a hypothetical altitude and run this. And so it gives a type of 3D rendering that runs the values from 0 to 255 or 0 to 254 to look for a 3D rendering of it. Now these values don't mean anything. They just mean lighter to darker. And I can change these as well. So if I were to change these tools for my hillshade and say, all right, the sun happens to be in the northeast part of the sky at a very low altitude, we'll say 20 degrees, we can run this. Oops. And I'll put in my DEM and run this. And so now you can see what these look like. And so now the hillshade, the sun is a lot lower. I put it only to be 20 degrees in the sky, so it looks a lot darker here. And so in conclusion, you can see some of the surface applications that we can run this using just DEM data, but we can run it with anything.